Okay, welcome to my second video in the series of videos. If you made it through the first one, congratulations, because even me looking back trying to watch it after, I had problems sitting through that one. It was pretty boring, but hopefully you at least, like I said, skipped to the examples you needed and those ones helped you. I haven't got any messages, people saying they're stuck, so I'm assuming you guys are getting this great, so wonderful. So you should have worked through the first lesson. You should have worked through the learning activities. And there's the answer key for those to help you. And then we're going to go through the second lesson. Again, there's another learning activity, and then you get the first assignment. So this one here is adding and subtracting rational expressions, which we're going to learn we cannot do without simplifying. So make sure you have the simplifying down before you come through and try and work through this one. Otherwise, you might run into some issues. I'm going to again skip over. This is right out of your ISO. Like, read through, give it a fair shake. One thing to realize though when we are adding and subtracting radicals is we treat them much the same as polynomials. In polynomials we could only add and subtract like polynomials, right? I can only add x's to x's, I can only add y's to y's, and that's as long as their degree was the same, so they have the same exponent as well. Radicals are the same way. Radicals are, we can only add and subtract those who have identical values under the radical sign. So the root 5s can be added to each other, the root 2s can be added to each other, and that's going to be as far as we can go. There are some further complications that go with this that are following the same rules, so nothing new, but we can discuss those as the time comes. Best thing I'm going to do here is just work through the very first example here, and I'm going to do this one a little different just to show you how this is in fact like polynomial. Instead of just jumping straight into this, I'm going to say, well, we have 3 root 5 plus 4 root 7 minus the square root of 5 plus 6 root 7. And this, I can show you how it's identical to polynomials in the sense that I can create these let statements. Boom. If I say let x equal the square root of 5, and if I say let y equal the square root of 7, I can rewrite this statement because I have my let statements and say, well, therefore 3x plus 4 root 7, which is y, 4y minus x plus 6y. I can now combine like terms, so 3x's take away 1 is 2x's, 4y's plus 6y's is going to be plus 10y's. To put it back into the original format, I got to put the root 5s back in for x's, and I could put my root 7s back in for my y's, so my final answer would be 2 root 5 plus 10 root 7. So again, like almost identical to doing the polynomials. I could have just jumped straight to that answer with originally, right? 3 root 5s take away 1 root 5 got me to 4 root 7s plus 6 root 7s got me 10 root 7s, but it's the exact same thing. Working through that is fantastic. So just a quick run through of the rest of these examples, just so you get the answers and make sure it works for you. So 3 root 2, just circling or underlining my like terms. I'm going to have 6 root 2's. I got the constants, 7 and 3, gets me 10. Straightforward, easy answer. Questions like this, again, some people still get easily messed up on this, and the way I do, I'm going to rewrite this out the entire long way just to make sure I don't get confused or lost, right? Don't get messed up in the simple steps early on, because that's just going to pay harder down the road. So I still have the 3 root 2 plus the root 3 minus 1. That trinomial is stated. I'm subtracting the second trinomial, so I'm subtracting everything, right? I'm subtracting the 3 root 3 that's in there. I'm subtracting the negative 2 root 2 that's in there, so that becomes a plus 2 root 2. And I'm subtracting the negative 1, that becomes plus 1. Now I can look for some. I'm going to start with this first term, 3 root 2. Do I have any others? I got a 2 root 2. So I got 5 root 2's. Spoken for. I got a root 3. I got to take away 3 root 3's. So negative 2 root 3. I got a negative 1 and a plus 1. And those are going to, of course, cancel off, and that should be my final answer. Example 2, exact same question as what we just did. The only difference here is going to be the fact that one of our radicals can be simplified, and that of course will happen very often. Do you see that? 5 root 3. So again, I'm just going to go to simplify this. 5 root 3s. I can break that root 12 into a root 4 times a root 3 and subtract root 3. So I got 5 root 3s plus 2 root 3s minus the square root of 3. So I just collect like terms again. 5, 7, subtract 1 is going to be 6 root 3s. Again, this is the math. We're just learning to collect like terms, simplify. You can always check your work on these ones, right? I can go into a calculator and I can type in 5 root 3 plus the square root of 12, subtract the square root of 3. And did I do this already before? Let me see if I got this. I did not, so I don't have them both. You can check that with your calculator, enter it in and see what you get. Then enter in 6 root 3 into your calculator and see if you get the same answer. That'll tell you if you're doing this correctly or not. All right. So here we go again, just more of the same thing. We'll just work through these very quickly to get you through. Nothing new, just looking for like terms, but we can't find like terms unless we simplify first. So this becomes root 4 times root 3 plus 3 times root 3 plus the root 25 times the root 3 equals 2 root 3 plus 3.
Continuation of our face upper serrated box.
So 2, 5, 10. I've got 10 root 3s. So that was that one. The next one is, I'm just jumping all over the place. I'm already ahead of myself here. Let's go to B, I guess. So this will be square root of 25 times the square root of 2 plus the square root of 25 times the square root of 3 plus the square root of 100 times the square root of 3. Simplifies to 5 root 2 plus 5 root 3 plus 10 root 3. Now that I have them simplified, I can look for my like radicals, and I do in fact have these last two. So again, the same question here. We're just looking for like terms. This answer will be in your book. You should end up, of course, with negative 3 root 5 plus 5 root 6 as you work through it, right? This can separate into 4 and 5. The 150 became 25 and 6, and the 125 became the 25 and 5, and we worked through that one. Again, like I said, I'm pretty sure if we can do the first ones, we can handle that, and that is explained in your booklets as well. So adding and subtracting radical expressions with variable radicands. Okay, so again, nothing's changed, same rules. We need to have the same variable to the same degree, like that always rule still happens. So it's working through that as best we can. We got 6 root x's minus 4 root x's plus 5 root x's. They all have the same radical, so I can combine these 6, take away 4 is 2, plus 5 is 7 root x's. These ones, they all look different, but they're not simplified again yet, so we've got to take a look through and see what we can. Now again, notice these are all cube roots, so we know the cube root of 27 is 3. We cannot find the cube root of x squared, so 3 cube root of x squared. Let's see if we have any like terms in the remainder, right? So minus cube root of 8 is 2, and we cannot, so this is going to be cube root of x squared as well. Then we have the cube root of 64 is 4 times the cube root of x squared. We look at, they're all indexes of 3, they're all cube roots. They all have the same x squared polynomial in them, so we can combine because all 3 of these are identical. So we got 3 take away 2 plus 4 is going to be 5 cube root x squareds. Okay, so this one is a longer one, and again, I'm going to try and speed things up for it. Again, if we take a look, if you need the extra help, again, I'm going to take a look and say, assume that you guys know how to simplify this radical. I know that you know how to simplify this one. As it turns out, this one is simplified as far as it goes, and the last one. So again, if you need to remember how to simplify, go back, but I'm going to try and jump ahead here to speed things along. Because the square root of 24 is going to be, this becomes 10x squared times the square root of 6x. Minus 7 at 54, which is 6 and 9, so 9 is 3, so minus 21 x squared times the square root of 6x. As you work through x squared, so this would be plus the x squared, that was simplified. And then the last one, it's going to be 16, so minus 4, and that'll be x squared is the square root of 6x. So again, if you look at simplifying each of those individually, you will see that this is in fact correct. All I'm looking for now is my like terms. So not only do I have to have the radical, what's under the radical sign matching, right? This is a root 6, this is a root 6x, this is a root 6x, this is a root 6x. But I also have to have the coefficients must be also the same term as well, right? So I got x squareds, x squareds, x squareds, x squared. So I can combine these. If one of these was missing, if this was just a 10x, then I couldn't add the 10x to the others. They have to be in the same format as well, these coefficients of each radical. But because this does work out to a 10x squared, I can still collect my like terms. So I got 10 minus 21 plus 1 minus 4, and that's going to end up coming to minus 14 x squareds times the square root of 6x. So again, seem big, seem long, you gotta be careful. It's harder to check these ones. When you are doing the other ones, we found if they were just like 3 root 3s plus 6 root 4s and collecting like terms, we could just enter that in our calculator. And this is a little more complex. We can still do that, but we'd have to come up with a value for x. Like what if x is equal to 2, and then plug that all in, and then plug it into our final answer. So you can still check the calculator, but it does take a lot more extra time. So be very careful with these ones. The final example in here, of course. Okay, take 17. So for the last one here, we're trying to find the perimeter of the entire shape. We are given the areas of these. Of course, as we know, square, the area of a square is the side squared. So to find the side is going to be the square root of the 60. So the side length is going to equal, right? Can we simplify 60 units? It's not a perfect square. What are some perfect squares that work? As it turns out, it's going to be root 4 times root 15, or the side length would be 2 root 15. Right? We do the same thing here. What is the square root of this to find the side length? And we're going to find that the side is going to be 3 root 3. So using that, we can now find the perimeter easy enough of this shape by just saying, what is this draw? So pick a starting spot. I'm going to start right here. So the perimeter is going to equal 3 root 3 plus, now we'll go to this side next, 2 root 15 plus 2 root 15 plus 2 root 15 plus, now this one again, I'm going to have to add on to this the 2 root 15, but it's going to be less one side of this, so this is going to be a 3 root 3, so plus 2 root 15 less a 3 root 3. Then I'm adding on the next side here, which is the 3 root 3. And then I'm adding on the final side, which is a 3 root 3. Now I know that this is not, I took the longest way possible. There are other ways we can do this, but I'm just showing you how we just need to break it down one step at a time, and we don't have to be overly concerned. All I'm going to do, look, I got 3 root 3s. Looking for my root 3s, I'm taking away 3, so I'm down to 0. And I got 2 more, 3 more, and 3 more. So I got 6 root 3s, so that's gone and spoken for. Gone and spoken for, gone and spoken for. I got 2, 4, 6, 8 root 15s. So determine the value of the perimeter of the combined in the simplest form. So the perimeter of this figure is 6 root 3 plus 8 root 15. Again, so it seems complex, and you're going to be like, my brain hurts. But as soon as you just jot down some work through it, it'll work itself out. Just have some faith in yourself, which is, why this is an appropriate comment. So again, good old me on the golf course. That's where I'm going to be in a few months to go, as long as I go golfing by myself and keep a social distance away from everyone. I hope that helps you guys with the lesson 2. You're ready for the learning activity, and then you can start on assignment 5.1. Good luck.